All right, let's begin. The first protocol I want to cover today is ModBus, not just with the CIMON PLC, but with the X panel and Ultimate Access as well. If you don't know what Ultimate Access is, that is our SCADA software. So that'll be covering our PLC, HMI, and SCADA software in relation to ModBus. So what is ModBus? This is probably the most common protocol in industrial automation. But if you don't know what that is, not a big deal. We're going to go over,
Really?
excuse, uh, we're going to go over the basic definition and how you would even get started with Modbus. This was developed by Modicon in the past. It's an open source protocol, meaning it's not the most secure one, but it is primarily the easiest to implement into like one of your applications. Anyone has access to the code. They can manipulate it however they want, making it not too secure. But at the same time, it's a free resource to everyone. So simply put, the protocol can be viewed as an universal translator. What does that mean? It means that two devices can communicate with each other that normally would not. Typically, almost every single device I have come across in industrial automation has the Modbus protocol, whether it be the serial or TCP counterpart embedded inside it. If it does not, I don't feel like, this is just my personal opinion, I don't feel like it actually is becoming a player in the market. Seldomly have I seen an industrial automation device not have Modbus, and I think it's been like one time. And it might be because it's not a secure protocol, it's losing interest, maybe. I know EtherCAT, OPC UA, Ethernet IP, and Profinet are like some of the newer standards, and MQTT is gaining some popularity as well, which is something we'll be talking about. So what are some common use cases of Modbus? Of course, in HMI or SCADA, talking to multiple brands, collecting data. Maybe you're not familiar with all those different protocols and you want to just collect data from multiple brands. Modbus is a fairly easy protocol once you understand it to use across the board. Maybe you want to control servo drives with Modbus. Maybe you're not comfortable using EtherCAT or analog signals. There are servo drives out there that have a Modbus interface, so that's one way of using it in an application. And having different brands of PLCs communicating. So if you want like a CIMON PLC to communicate with an Allen Bradley PLC, one of them could be the Modbus master, one could be the Modbus slave, and they could exchange data that way without using a gateway. So a gateway, an example would be maybe like an HMI. So typically, some people will use an HMI to bridge the gap between two PLCs, and that is not always necessary when you have a common protocol like Modbus that just bridges the gap. All right, so what do Modbus registers even look like? What is this? What is this beast, right? So we have, of course, read-only registers, and then we have read-write registers. So for the read registers, we have discrete inputs. So I mean, those would just be bits. So those are read-only bits. So each of these tags, we'll call them tags or variables right now. Each of these registers are just one bit. It's not a whole word. The whole word is when you get to input registers. So 30,001 is a whole word. It's 16 bits. 10,001, that is one bit completely. So it's not 16 bits inside this one register. So one bit, one bit, one bit. So it's 3 bits in a row, right? And then we have three words right here, 30,001, 30,002, 30,003. So commonly referred to as the ones, the threes. So the way I remember it is the odd numbers, ones and threes are read only. And then for read write, the even numbers are read write. So zeros and fours. So just like we saw on the left-hand side, on the right-hand side, your zeros are bits and your fours are words. So 1 bit, 2 bit, 3 bits. So these are each of these data registers are a bit. And then each of these data registers down here are a word. They are 16 bits each. So you might be wondering, well, if it's only 16 bits, how do I do like float communication if it's 32 bits, or how do I do double word communication? Now, typically that is dependent on how the client is interpreting the data. But if you target 40,001 as a double word, it will grab 40,002, understand the bit orientation, and then compute the value of the double word or the float. whichever comes first. And then there are ModBus protocols out there, or since it's open source, there are ModBus protocols out there that handle 64-bit data communication, which ours does on Canvas. So I will get to that later. So basic understanding of ModBus registers is that we have zeros, ones, threes, and fours. Your even numbers, zeros and fours, are read-write. Your odd numbers, ones and threes, those are read. I'm talking about the prefix, the first number in the sequence or in the permutation. So anyway, those are ModBus registers, and it'll make more sense as we kind of go through the presentation. So we have what we call ModBus functions. So most of the time the client will handle it. It just depends on the interface you're dealing with. So if you're using our PLC software, you will need to be very specific about the function code you're using. But if you're using our HMI or our SCADA software, it will combine these function codes into like it'll combine it for you instead of having to like explicitly state the function code you want to use. For example, say you wanted to read and write from a 4 register, you would have to use the function code 3 and function code 6. So the HMI will combine both of those together, but our PLC software separates them. So you would have to do a 6 and then a 3, or a 3 then a 6. It just depends on the software that you're using. So more often than not, a client software will combine both function codes together. So the function codes, in my opinion, are not super necessary to understand. Just like typically they are always coupled with the function name, so you don't have to memorize the number, but they're always there for your reference. So the reason I put this slide up is to show you that we do not support multiple coil writes with the PLC software. So you got to remember, this presentation I'm showing you right now is orientated for our PLC. So we do not support multiple coil writes on the PLC, so you'd have to develop multiple frames for writing a single coil. But we do support writing multiple words at the same time with the ModBus protocol. So anyway, these are the different functions that we support. We don't have to read too much into this. It's basically you're reading a bit. We already know that that's true, right? The ones, they were read only. Then we had read write, that's true with the zeros. And then we had read only with the threes. So that again is a word register. So when you see register, typically that means, or that does mean word, right? So we either have holding register or we have input register. So input register meaning read only, holding register meaning read write. And then we have inputs and coils. So discrete inputs or coils, those would mean your bits, right? So when you're looking at the function name, it kind of just gives it away. So let's go over some ModBus examples. If you were to use a CIMON PLC and you're talking to, let's say, a Micrologix, I just chose a random PLC, so I thought Micrologix would be a pretty good example. Inherently, we cannot bridge that communication with our PLC to that PLC because we don't support Ethernet IP on the PLC for now. But that's why I have a bunch of these red X's right here. So we cannot bridge this communication gap between a CIMON PLC and an Allen Bradley PLC. Now, if you're talking about a CIMON HMI, that's a completely different story. Of course, we support Allen Bradley's protocol, Ethernet IP. But as far as the PLC goes, we only have a couple protocols on the PLC, one of them being ModBus. So that would be the example I'm giving right here. Now, an M register on CIMON is similar to a B register on Micrologix. A D register is similar to N. A Y is similar to an O. An X is similar to an I. Now we see that I put an X over the X down here. These are both read-only registers, so this is pretty problematic because you're trying to write onto a read-only register either way you go. So if the Allen Bradley PLC was the master and it was trying to read from a CIMON PLC, you wouldn't be able to use a read-only register to write onto a read-only register. That doesn't make any sense. So you would need some type of register that is read-writable on the client side. So I'm using the CIMON PLC as a client in this example. So I'm using the 1 register, so we're reading a coil from the Allen Bradley side. We're going from right to left here. So the slave is on the right-hand side, the master is on the left-hand side. So you'll see that I put an X over the X register because this was a read-only. This is a physical input, just as I is a physical input. So I'm changing this to an M register. It would be more appropriate to store the status of an I register to an M register or some other register that is read-writable, because you will not receive the interaction that you're looking for. Everything else is good to go because these are all read-writable registers. Even though Y is physical output, you can read and write to it as though it was a marker bit or some other bit of that nature. Same thing goes with O. So the rest of this works just fine. You just need to be very careful when you're talking about the ones or like a read-only register. Make sure you're using the appropriate data register on the client side, of course. So that's just an example. Now, there are some considerations. Not everything is crystal clear when it comes to ModBus. Like I said, it's an open source protocol, so people can make changes as they see fit. So you need to take into account that there's one based versus zero based. One based meaning the starting register is at 1. Zero based meaning the starting register is at 0. So how does this affect you when you're using ModBus? Well, it might not always be 1-to-1. So if the user manual on the slave device says 0001, you don't know if that's 0000 or 0 all the way through, because you don't know if it was 1 based or 0 based. So this becomes a heavier consideration when they don't even show the starting register at all. Say they show you the register. So I'm going to open up Notepad here. So say they show you something like this in the user manual, right? If they show you a register like this in the user manual, then this, you don't know if this is actually truly 40,354 or if it's this register or if it's this register. There's sometimes a little bit of guess and check when it comes to ModBus because it's not natural, or it's not always natural, right? So as I said, the difference between 1 and 0 base could be the difference right here. You could be dealing with a 0 base, so you have to account for offset of 1. It could be naturally 1 based, and then that would be the exact address you're using here. And then sometimes they messed up on the numbering, and you might need to use the neighbor register. So always experimenting with the neighbor registers is important with ModBus if you're not getting the value that you're looking for. So that is the distinction between 1 and 0 based. There's an expanded ModBus range. So prior to, like, I want to say the 2000s or whenever this came out, you would only have available of 10,000 registers to you. So that's 1 through 9,999. And that's just because that's when it was developed. We didn't think that we would need these many registers. Well, that has changed, obviously, as technology has grown. So now we're able to handle up to 65,536. So a full word of registers. Well, I mean, the full range of a word, right? Not like full word, not 16 bits. We're talking about like the value of an unsigned word can be 65,536. So there's the expanded range for ModBus. And then, of course, there's hex to decimal. So some ModBus interfaces might be in hexadecimal and some ModBus interfaces might be in decimal. That doesn't mean that you can't communicate with one another. So if the user manual of the slave device you're talking to is hexadecimal based, all you have to do is take the hexadecimal and then transmit it to a decimal form using a calculator or something of that nature. I'm not going to be able to do that off the top of my head. But and then you would take the true value, the decimal value, and then that would be your IO address. And then I guarantee you that will communicate with the hexadecimal address. The packet will take care of the translation for you. So, and it's not, I don't want to say it's magic, but that's just how the protocol was developed, of course, right? So I've had my fair share of hardships dealing with ModBus, and I noticed that you can just take care of the hexadecimal address by transferring it to a decimal form. So with our XPanel designer, XPanel, it doesn't support hexadecimal ModBus, so you can do something of this nature to overcome that obstacle. So PLC as a ModBus slave. So we were talking about being a client for a little bit there, so I want to talk about being a slave. So It's pretty easy to use the PLC from CIMON as a ModBus slave. Inherently, it is already set up as one for you. So when you go into the PLC parameter, I'll open up the CIMON software for us to kind of showcase that. So in the parameter branch in the project tree, we have the PLC parameter right here. And then if I go to the ModBus tab right here, it's already set up for you. So as soon as you download a project to your PLC, it will already be a ModBus slave unknowingly. So even if you're not intentionally doing it, it will already be one. Now, that won't mess up with your communication unless you're talking to multiple slaves on the same network, just be mindful that the slave ID does not match anything else on your network, or you might have a bad communication elsewhere. So let's go back to the presentation. So it's natively active. You need to match the communication parameters. What does that mean? Make sure that your channel 1, your channel 2 serial parameters are correct if you're using 232 or 485. It's very dependent on the baud rate, the parity, data bit, and the stop bit. Those need to be matched up accordingly. You don't need to worry about station number because station number is tackled within this tab right here. The slave ID is going to be your quote unquote station number. So configuration tab is the same for RTU and TCP. They both share the same ModBus tab is what this is saying. So other than just like the data register setup, you just want to make sure that your Ethernet IP address is set up correctly or your serial channels are set up correctly. You want to be careful about the hex hops. Now, this has become less of a concern lately because what we have done is we've added tooltip displays for you. So if you just hover your mouse over the contact, the coil, or any instruction for that matter, it will tell you the value for your ModBus or for your data register immediately. So like as we see in this picture right here, Y10 is automatically shown as 17. Now you might be wondering, how is that possible? Why is it not 1-to-1? As we see over here, x00 is 1. So if we look over here on the right hand side, we see that y0 is 1, right? Like that would be the misleading part because you're like, oh, 0 is 1, so therefore 10 should be 11, right? It should just be 1 off. And that's why I give this helpful tip right here. Careful about the hex hops. So like in Mitsubishi or Omron PLC, the PLC for the CIMON is a hexadecimal based data register. So meaning instead of showing 10 through 15 for the bits, we go A, B, C, D, E, F. So that can be misleading when you're using ModBus because A is actually your 10, which would be ModBus 11, and then B would be 11 being ModBus address 12. So I'm going to show that on the notepad real quick to kind of be more explicit. Okay. So the next one in line is not Y10. You would think it is, but it's not. So we're actually going to go up one. It's going to be Y0A because we're hexadecimal based, correct? So this one is actually your 11. So that was the misleading part, right? And then this would be 17. So this is only an issue when you're looking at the bit registers because the bits have hexadecimal based addressing within them. If you're looking at the D registers, it's fairly simple. If I had D400, it would be 40,401. It would be a very simple translation with the word registers. So just to make that picture clear again. So if I had D4, like D01 is 40,002. I should start at D0 though. So this is true. This is also true. And we can skip a bunch. And then this is true. So nothing really changes with the D registers. It's a one-off, if you may, right? But with the Y's and the X's, it's a little bit different because of the hexadecimal hops. Now, we've overcome this recently. I used to show customers a formula that would pretty much easily cover this. but now you can just hover your mouse over a or over an instruction and it will tell you the ModBus address immediately. So just be careful when you're doing the bits. So if you're going to use ModBus from our XPanel designer or from Canvas, just setting up the I/O device is pretty simple. I'm having the HMI be the master and the PLC be the slave, of course. And I don't know if I have XPanel designer. One second, I do. So let's open that up. I'll show it from XPanel designer side, and then I'll show it from Canvas side as well. So it's fairly simple. I don't want this one in here. So when you're creating an I/O device, it's over here on the left-hand side. This is XPanel Designer. This is our legacy software. We're now going to be starting to use Canvas, start pushing that software. But over here on the I/O device, click on New Device, Ethernet, give it a name. And then I can choose ModBus from our list down here, ModBus TCP. Choose TCP station, add a station, give it a name. Network ID is your slave ID, so whether that be whatever it is, and then just some IP address of the slave. Press OK, and then done. You've created your ModBus I/O device. It's pretty simple. So then I'm going to go into the tag database and then show you some examples. So we have dig, choose real tag, go over to I/O device, choose the I/O device that I made, and then maybe I want to talk to this data register right here. So I choose this register that corresponds to whatever bit from the user manual that I'm trying to talk to. So in the PLC, this might be B300, or I think it's like this actually. So something like that, or it could be servo start. It could be a servo start inside the user manual of a servo. It just depends on what device you're talking to, right? The user manual will tell you what register or what this is trying to control, whether it be a data register in a PLC or whether it be like some type of mechanism within the device you're talking to. So I'm going to leave that one alone, and we're going to create another one. So how would I do analog? Same thing. So I'm going to call it Anna. We click on real tag, I/O device. We're going to choose the I/O device that we made, and then 40,001. So pretty simple. We can take it one more step and then change it to int16 and then press OK. Now, what if I wanted to talk to a float over ModBus? So I mentioned this earlier, but I just want to reiterate it. So let's say we target 40,002 as a float. If we come over here, we have to target it as a float. So we choose float. So what does that entail? 40,002 and 40,003 are going to come along for the ride when we're talking to this ModBus address. It's going to take both of those registers, combine them together, or conjugate them, right? Or they're going to combine them together, truncate, whatever word you want to use, and then it will decipher the orientation of the bits and then produce the correct float. Now, if you do not get the correct value, regardless of choosing float, that might be a little Indian, big Indian issue. And with that, we support 16-bit and 32-bit data swap. So that might be the case. It might be a little Indian, big Indian type complication. And like I mentioned earlier, ModBus is open source, so different companies do things differently. You can just take that into consideration if you're getting the wrong value. It might take a little bit of troubleshooting, but once you get there, you'll be fine. All right, so that is from the XPanel side. And also take note that the XPanel can be a ModBus slave as well. So that way, like a SCADA server or some type of other server or some other type of client could talk to it, right? So you could turn the XPanel into a ModBus server. It doesn't always need to be a ModBus client or a master. So now I'm going to open up Canvas. It's the same thing, essentially, it just looks different, right? I'm going to turn this into the light view for us. So same steps, just different order or different locations, right? So we're going to open up the I/O device editor found here. And then I'm going to delete this protocol. We're going to add a protocol. We're going to go ahead and choose ModBus TCP right here. I'm going to press OK. So pretty simple orientation or configuration rather. We have the swap 16, 32, 64. We have a bunch of swaps depending on which one you want. We've segregated them into their different classes of data types, making it simpler on the user. So maybe it's just the floats that are little Indian, big Indian issues, and we can leave the other ones alone. It just depends on your application, right? And then you're going to change the IP address down here, and then you're going to change the ModBus slave ID down here. And then you press OK. And then when you create the tag, it's the same order of operations. And we're going to choose the IO device that we made, new device. And then I can just put in my address here. So pretty simple. That's pretty much all I really wanted to talk about for Modbus, showing how the basic configuration happens. I think we will show it from the I'm going to briefly talk about it from the Modbus master side on the PLC, and then we'll call it a day on Modbus and move on to the other protocols. So make sure that your COM parameters match. That's what this slide is trying to show you. We already went over how to create a tag, so I'm going to just slide through all of these. Okay, so I will be giving this presentation and all other literature I'm going over today out to you guys. So don't worry about me grazing through these slides too quickly. You'll get the recording, you'll get the slides, and all the other literature that I'm going to be talking about today. All right, so this is the PLC as a master. So this is what I was talking about, those function codes that we don't need to memorize. There's the 0, there's the 1, 2, 3, 4, 5, 6, and 16, right? So those all have their own different meanings. If you look at the actual verbiage, it will tell you what it's doing. And then it will give the data register orientation on the right-hand side. So like with the 0, the 1, the 4, the 3s, all of that nature. Just make sure that you're talking to the correct device. You can do auto polling or not. You can transmit automatic or manually. So there's a little checkbox down here that chooses. You can control the rate of communication with your Modbus client or Modbus server rather. And what else do I want to talk about this slide? When you create a new program within the CIMON software, how do you do that? You do that by right-clicking on the program. You go to New Program, and then you can choose Modbus Master here or here. So I'm going to choose RTU, make this simple on us, and then we're going to add a frame. So you choose the slave ID right here. You choose the function that you're going to use. So maybe we want to read some 4 registers, and then we'll start at address 1, and then you choose your little Indian, big Indian style. And then data size could be, maybe we want to do 5, and we want to store the D0. So what this is going to do is it's going to take 40,001 all the way to 40,005, all 5 of those registers, and store them to D0 through D4, all 5 of those registers. And then we could choose to not transmit that automatically by checking the checkbox right here, but I'm going to let them transmit automatically. And then you need to make sure you're choosing between 232 or 485. So you want to be careful on what interface you're using, communication interface, and then the slot number. So whether that be the CPU or a communication card that you've expanded with. All right, so that's pretty much all about Modbus. If you're going to control it manually, you're going to be using this instruction right here. Master to slave communication is using the send instruction. Master to master communication is using the receive instruction. So program ID, the required H, 0 being the channel, or 1, like 232, 1 being channel 2, Ethernet, so forth and so forth. I'm going to kind of like, speed through this because we need to talk about other protocols and we're kind of tight on time, I believe. I think we have 30 minutes left. So, and then there's the frame number. The frame number is like the unit, or it's the classification over here on the left-hand side of what it's the identifier for your frame, right? It's the identifier for this segment of your program, right? So this one would be 0 here. And then we have the result, which is going to tell you the communication status, whether it's, good or not, for lack of better words. So if it's a 0, that's showing good communication. If it's a 1 or any other value and it's stuck on 1, that might mean that the communication between the master slave or the master has had a hiccup. And that's one way to troubleshoot your communication, is to look at the resulting flag of the data register. All right, so let's just move on through all of this. Okay, so troubleshooting tips for the PLC. Um, on the bottom right-hand side, this is not exclusive to ModBus. This is exclusive to, or this is for any type of communication you're doing with the PLC. So if you're using serial on the PLCS, you'll notice that there are 4 LEDs at the bottom right-hand side of the PLC that will illuminate and flash very quickly or rapidly, right? If it's communicating effectively. If it's not illuminating or rapidly turning off and on, that means that it's not working. Like if it's not blinking at all, it's not working. And the same thing goes for the Ethernet port. If you plug in an Ethernet and the check light is not on, or the communication light is not on, that means it's not working accordingly. Now you can also check to make sure that the PLC is not the culprit in the communication bridge. There is a tool that I love to use when it comes to ModBus. It's called ModBus Pull. Now it's a free tool for 30 days. You can purchase it after that. It's a great way of troubleshooting a server or some other type of device that you're having a difficult time communicating with. So all I have to say about this is if Modbus Pull can talk to the Modbus slave that you're talking or you're wanting to communicate with, our PLC can definitely do it as well, or our X panel or the SCADA can do it. So Modbus Pull is like my gold standard for troubleshooting a Modbus slave. So just wanted to throw that out there. And that's pretty much it for Modbus. So let's talk about some other communication protocols finally. So I want to talk about MQTT. This is like the new bad boy on the block, right? It's a cloud-based protocol. It can talk to AWS, Azure. It's a neat little protocol. It's lightweight. It lessens the bandwidth on your already made industrial automation application devices. So not every single device can keep up with the technology that we're inventing today. You want to use your old devices, your serial interfaces, et cetera, but you can't necessarily push that data to the cloud. So how do you push something to the cloud that is on a serial interface? Well, you can use a gateway, you can use an edge of network device. So we can send the data from the archaic device, the historical device, the ancient device, right? We can send it to a gateway or to like an HMI, for instance, like a CIMON HMI, because we have edge of network computing. We have 2 Ethernet ports, by the way, so that really makes it easy to have one Ethernet port dedicated to the LAN network and one dedicated to the WAN. The WAN going to your cloud server, so whether that be AWS, Azure, or some other type of cloud computing or cloud server that you have hosted. So simply put, if you don't know what MQTT is, I like to describe it as the manufacturer, distributor, customer mindset, or like the workflow, right? So the manufacturer, it would be very hard for them to deal with every single customer that wants their device, that is purchasing from them. So that's why manufacturers hire distributors. So in this model, MQTT has 3 different types of interfaces. It has what we call a publisher, a broker, and a subscriber. So the publisher is the manufacturer. The broker is the distributor, and then the subscriber is the customer. So I'll try to show that down here. We have the publisher on the left-hand side. We have the broker in the middle here, and then we have the subscriber being the end user, or whether it be like an iPad or a computer of that nature, or it could be the cloud. So whatever it is, we're going to call it a subscriber. It's the end device in the linear fashion of the communication known as MQTT. So the publisher being the manufacturer, aka CIMON, we are the publisher with our HMI. We are going to send data to what is called a broker, which is going to be responsible for the distributor. So, excuse me, a very common broker that I like to use is called Mosquito, and I'm going to show a YouTube video here of me actually giving a live demonstration. Well, it's not really live because it was recorded, but me giving a demonstration of the different parts that are that go into work when you're using MQTT. So I'll be using a CIMON HMI as the publisher, I'll be using Mosquito as the broker, and I'll be using MQTT FX as the subscriber. So it would be nonsensical to have the manufacturer talk directly to the customer because that causes a lot of burden and bandwidth on the manufacturer. That would not be an ideal setup. That's why we hire distributors, aka brokers, to handle all of that communication. So the broker's main detail, its main job is to handle all of that incoming bandwidth and to send data to the customer when it when it has subscribed to it. Another great attribute about this protocol is it's not a polling based protocol. It's a subscribe based. So once the customer or the end user, the subscriber has subscribed to the distributor for a certain tag value or a certain other, variable, it will only receive updates when that value has changed. Otherwise, it will retain the last kept value. It will cache it, right? So when the broker receives a new value from the manufacturer, it will then relay that message to the end user, the subscriber. So there's not this constant polling back and forth causing a lot of bandwidth. So this is a very lightweight protocol. It's a cloud-based protocol, and it's a very effective and efficient protocol. So I wrote a blog article about this. We put it on our website. If you're more interested about reading it, go to our website, look for the MQTT blog protocol or blog article. It kind of encompasses everything I mentioned here. I love describing this as the publisher or the manufacturer, distributor, end user model. Again, the three different components, because you might be used to hearing like master, slave, or client server. We have publisher, broker, subscriber. So to put that in layman's terms, this interface right here, publisher, broker, you could think of it as like a server client model. The server being the broker in this instance, and then like the publisher being the client is pushing data to the server. And then the broker will be the client in respect to talking to the subscriber, or pushing data to the subscriber. Or I guess you could think of it the other way, the subscriber is the client. I guess the broker would just be the server in this model. It's not a clear-cut client server example. That's why it's kind of hard to talk about it. That's why they didn't really use the terminology client server in this model. It's better to just become more familiar with publisher, broker, subscriber, get out of your comfort zone and step away from the client server modality and just understand it as publisher, broker, subscriber. It's easier to think about it that way than trying to relate it to server, client, or master slave, right? So publisher takes data from its own devices, sends it to the broker. Broker then holds on to it as a reservoir and then sends it to the subscriber if the subscriber is subscribed or if there is a change in data. And just to reiterate, the CIMON HMI, the new HMI, the NXT or EXT, is a MQTT JSON publisher. So let's take some time to watch a video. So that's a pretty neat little example I have there. If you want to see it again, you can always go to our channel on CIMON. We do have a bunch of videos that showcase the Canvas new features. So I'm going to step away from MQTT right now, and we're going to jump into OPC UA. So we have a couple devices that support OPC UA. We have OPC UA server on our PLC. Yes, you can use it is not up to date on the certificates. So if you're using something like Kepware, that always stays up to date on certificates. It might not communicate effectively, but our HMI, so the NXT-EXE is always up to date on the certificates, and so is our SCADA software. So we have two interfaces that really take advantage of OPC UA server and client. Our SCADA software can be both, and our HMI can be both a OPC UA client and server. Now, if you don't know what OPC UA is, I like to compare it to the new generation ModBus. The interface is very simplistic, and so is the I/O addressing. It's even more simpler than ModBus when it comes to I/O addressing, because typically it's just the name of the tag itself. The I/O address is the name of the tag. So I'm going to open up the SCADA software real quick, if I can find it. Okay. So if I go to I/O devices and they go to new device, this is our SCADA software, by the way. It's called Ultimate Access, otherwise known as CIMON. On Thursday, I'll be going more into this software, or I'll be going in heavier detail. So you'll see that we have OPC UA or OPC Client DA. So this is the older variation of OPC UA. And then we have OPC Client. So this is the UA variant. So it's very simple. If you have a server that is pingable, right? That is the key here. If it's pingable, you'll be able to find it. So you just press searching server and it will find it on its own, which is pretty nice. It's very easy. And then you're going to press OK. It can grab all the tags for you, but just for simplicity's sake, I'm going to show you how easy it is to make a tag. So let's say I want to make a tag, right? Call it tag. And then in 16, we're gonna choose that I/O device that I made. This is the OPC UA client, right? Or server, rather. We are the client here. So let's say that you had a tag on your server called pump1. Then it would be pump1 over here as well. Whatever the name of the variable is, whatever the name of the tag is on the OPC UA server, that will be the I/O address on the OPC UA client as far as CIMON goes. That's how easy this protocol is. There's little to no chance that you can mess up with your I/O address declarations. And it makes using a spreadsheet a lot easier. Now you can see the appeal to this over ModBus, because ModBus, you have to take that one extra layer of understanding, like your zeros, your ones, your threes, and your fours. When it comes to OPC UA, it's literally just the I/O address name. It's the name of the variable or the tag. It makes it very simple to communicate with. Additionally, the CIMON SCADA software can also be a server. So likewise, the client, whatever client you're using, OPC UA client, that will be using the I/O address, the tag name from the CIMON software. Let's go ahead and show this from the Canvas viewpoint. Where are you, Canvas? Okay. So I/O device settings, if we look here, I'm gonna click on new device, we'll see that we have OPC UA client right here. It's a little bit more sophisticated in Canvas. You will have to declare the IP address. There is no searching server feature in Canvas. Unfortunately, I will talk to the developers about that. But there's an IP address right here that you're going to insert. That'll be the IP address of the server. Now, your OPC UA server could be AWS. It could be Azure. They do support this protocol. It's an IoT protocol. It's not just meant for industrial automation, right? So that's the beauty of MQTT and OPC UA. It helps bridge the gap between the non-industrial world and the industrial world, because let's face it, we're behind times in terms of industrial automation. And these protocols, they're so valuable because they are very secure. They require certificates. They require a lot of authentication if you want it to happen. There's a lot of encryption. So they're very hard to crack. It's not impossible, but it's not as easy as ModBus, because as I mentioned earlier, ModBus is open source, and basically anyone can understand that frame structure. It's very easy to get a hold of. So if we look at all this other all these other parameters here, we'll see that there's a URI, so that's the URL that you'll be pointing at for the OPC UA server. You can enable encryption if you want to. The authentication method, you can enable that as well. And then once you do that, you're pretty much done. You can press OK. You've created your IO device. We can come over here to Dig. We can choose the IO device that we made. So there was new device 2. That was the OPC UA server that we created, right? Or client, because we are the client. And then I'm going to choose the IO address. Maybe it was pump 1 status. Maybe that was the name of the tag over in the OPC UA server. Again, the tag or the variable in the OPC UA server is going to be your IO address over here in the client side. That's how it's so simple. That's why I love this protocol. It's very easy to use. There's very little to no room to mess up with your IO address declarations. Likewise, with being an OPC UA client, the X panel, the NXT-EXT can be an OPC UA server. So we have the capacity to being an OPC UA server. You will have to provide your own certificate, of course, and all that fun stuff. We don't provide that for you, but we provide the capacity for that. That's just for you to decide if you want to use that or not. I recommend taking full advantage of that, because otherwise you're basically just using ModBus. Always take advantage of the authentication, the encryption, and the certificates of a protocol that provides it. Again, it's like that's the whole point of this protocol, is to be very secure and safe. I guess another synonym for secure. It's supposed to be a safe protocol for you to use in this field, because there have been plenty of times where someone has tried to put their application on a WAN network and they get hacked the next day, and they're like, what's going on? Cybersecurity issues are just becoming more rampant and more rampant as technology evolves. So to stay above that, or to stay ahead of the curve, you need to be using secure protocols if you're going to use any type of cloud-based communication or whatnot. Otherwise, you can just stick to what works, and that's called the air gap. If you don't know what air gap is, just take your application off the network. Air gap means that there's no communication going on between your application and the real world, right? Air gap meaning nothing in between. So that is probably your best line of security. The only thing that could probably beat that is a coworker or a worker, right, that has nefarious actions. They can pretty much dismantle your project if they wanted to. But to protect yourself from hackers, the outside world, an air gap is your best line of defense, of course. Okay, so that was OPC UA. So just let's remind ourselves what we went over here. So I'm gonna write that down on the notepad. Where are we going here? So for the CIMON PLC, it can be OPC UA server. For the HMI, it can be OPC UA client or a server. And then for SCADA software, we can be an OPC UA client or a server. So you have a lot of tools on your, you have a lot of tools in your arsenal when it comes to the CIMON products. You can use any of our devices pretty much as an OPC UA server or client. So let's move on to TwinCAT. So this is a pretty formidable protocol, just like OPC UA and MQTT. So when I talk about EtherCAT in respect to CIMON, I am not talking about the EtherCAT protocol. So we have two types of protocols for EtherCAT on the CIMON products. We have an EtherCAT master, which is primarily meant for talking to servo drives. And that is found on our CM1 series of our PLC. So as long as you have the ESI file from your servo motor, you can import that into our PLC, and it will be able to talk to your servo drive using EtherCAT. You'll be able to do all your trapezoidal curves, any of your stop and start axes. It has 8 axes control, so it can control those big robust arms that you see at trade shows over EtherCAT, what have you. But what I will be primarily talking about today is the EtherCAT slave interface. So this is how you can take full advantage of CIMON's I/O devices, like the I/O slices, like the digital inputs, the digital outputs, the analog inputs, and the analog outputs, using EtherCAT remote I/O. Yeah, you heard that correctly. CIMON has EtherCAT remote I/O. So without even needing to understand or utilize the CIMON CICON software, which is our PLC software, you don't even need to understand or use it. You can control our modules at a budget price, right? By just interfacing with the I/O, like controlling the inputs, the outputs, whether they're on, off, reading the analog values, the current, voltage, or temperature. So simplistically putting, I'm just going to walk through the different steps. And if you don't know what EtherCAT is, it was a protocol developed by Beckhoff. Their software-based program on their computer or on the computer is called TwinCAT. So this little tech note that I created is a perfect example walkthrough that can help you actually communicate with any type of EtherCAT slave, but primarily it's focusing on ours, of course. And I'll walk you through the steps. I'll kind of talk about it. In this example, I am talking to a relay card from the CIMON side. So I'll be turning off and on a relay point remotely using a computer using CIMON's PLC I/O cards. So you don't need a PLC at all. You just need the I/O card. That's how amazing this protocol is actually. You remove the need or the necessity, or you remove the necessity, or you I'm just stumbling on my words, so I'm sorry, guys. So you remove the necessary requirement of needing a PLC CPU, right? And then so you just need the relay card itself. So let's just get over that hiccup. All right, so in the PLC software, if you go to the Tools tab and you go to the drop down, you'll see the EtherCAT option here, and you'll create the ESI file. So what an ESI file is, that is the HTML file, or it's the XML file. It's the XML file that you import into the master. It simplifies the whole communication process, correct? So you click on the tools drop down, go to EtherCAT interface, create your ESI file. It will automatically generate it for you, depending on which modules you select, right? So if you select the relay card, as I've shown here, press create. It will give you this message right here that says, hey, we created the XML file correctly, and it's in this directory for you, right? So that's all you need from the CICON software. After that, you don't need it anymore. Once you create your ESI file, that is the common file for EtherCAT, you're done. You're done with CICON. You don't need it anymore. So you're going to go take that XML file wherever it got stored. So in this example, it got stored in the C drive, CIMON, CICON, English, EtherCAT, blah, blah, blah. You'll go take that XML file, you'll copy and paste it into your EtherCAT master directory or your EtherCAT master device, whatever the directory is on your own device. For this example, I'll be showing TwinCAT, which is Beckhoff's software that exists primarily on the computer. So you'll go and paste that into the directory. This is the directory that is default to computers, C drive, TwinCAT 3.1, etc., etc. So you'll create a TwinCAT project using XAE. So that's the XML format. So that, again, that's the ESI file. And then you're going to add a new item. So this is what it will look like on the TwinCAT side, the TwinCAT software. That's their proprietary software. You'll add a new item. You'll say that you're going to be an EtherCAT master because we are the EtherCAT slave. Remote I/O, we are always going to be the EtherCAT slave. And then you're going to select the correct interface on your computer. So here we have, we're going to be using Ethernet, of course, right? That's what we're always going to be using. So we're going to be looking for the Ethernet NIC card or the correct interface to use. And if it doesn't show up, you might need to go through some steps to actually embed it into it. And I kind of give those examples right here. And then I believe, where was it? Yeah, so you're going to select the adapter tab. You're going to look for compatible devices. It'll show up in the Ethernet adapters here. You're going to click on it, click install, and then after that, you can go back to the interface that we showed before, and then you select it, press OK. So basically, you're just looking for your Ethernet port that that you will be using to communicate with the EtherCAT slave device, which is known as the ET10S module. So you'll take the ET10S module, which will take place of the CPU, the PLC, and you'll just put the relay card onto it, and then voila, you have an EtherCAT remote I/O. So then you'll scan it. If it scans it properly, it will show up like this. It'll show up as ET10S, and you'll see that it's all digital outputs because the relay card that I'm talking to is a digital output card. It's all relay outputs. If you ever catch me at a trade show, I usually hook up a little LED lamp to our relay card, and I can control it from the CPU or from the PC, right? The PC that is running the TwinCAT software, and it's pretty simple. It'll show up like this in the software. You'll press right click, online write. You can write a value into the register. So if I wrote a 1 here, it would turn on the first bit, right? Because bit 0 is a 1 or is a 0, and then bit 1 is going to be 0 or 2, bit 2 is 0 or 4, and so forth, binary wise, right? So if I put the number 5 in here, what is that going to do? It's going to turn on bit 0 and bit 2 because that's 1 plus 4, right? So it'll turn on those 2 bits, so you'll be turning on those 2 outputs on the relay card. And that's basically all you have to do. So again, let's refresh through those steps. All I did was download the CIMON software. I create my ESI file by declaring which IO modules from CIMON I'll be using, and then I don't need the CIMON software ever again. I take the ESI file, I import it into my EtherCAT master, and then I scan the device, make sure I can detect it, and then I can control the IO from there. So whether that be another interface that you have, or whether that be the TwinCAT software that you're using from Beckhoff. So whatever it might be, at the end of the day, it's the same type of communication. So you're importing the ESI file into the master, and you're controlling the bits, the words, or you're reading the bits and the words from the remote IO. So we're running out of time here. We have one last minute, and I wanted to talk about Ethernet IP. So for our old X panel, so the IXT and the XT, the way that we used to communicate with Allen Bradley was through the L5X file. That was a very easy way of doing it. You take the L5X file from the PLC software, and if you don't know what that is, for most, that is the through Compact Logics or the Control Logics, the Studio 5000 software, you can save the project file as an L5X file type. And then you can import that into our XPanel software, and it will grab all of the IO registers for you. It will make everything for you. It's a very simplistic feature. So if you want to take advantage of that, you want to use our older XPanel, the IXT or XT, you just take the XML or the L5X file, import it, and voila. It creates all of them for you. Now, the limitation here is it only talks to the Allen Bradley PLCs. This is not true Ethernet IP. This is just the subset of Ethernet IP for the Allen Bradley logic controllers. Now, on our newer software, the Canvas software, we now support Ethernet IP overall. If it falls under the scope of ODVA, which is, I guess that's the certifier of meaning that you can actually communicate with. It's the certification organization that declares that you are capable of communicating with Ethernet IP, right? So you're going to want to select this protocol if you're going to be talking to any generic Ethernet IP device. Otherwise, we have Allen Bradley Ethernet IP up here as well. Take note that you can actually talk to the micro 800s, the micro logics, the compact logics, or the control logics using this protocol, Allen Bradley Ethernet IP, or the ODVA Ethernet IP. This can be used for Ethernet remote IO. If you need to talk to Omron over Ethernet IP, you need to talk to a Koyo over Ethernet IP, you need to talk to a VFD over Ethernet IP. I mean, I'm gonna hurt myself by I'm repeating this over and over again, right? You can talk to anything that supports the Ethernet IP protocol under the standard of ODVA. So don't get stuck on the whole ODVA prefix there. That's just to reiterate that it is certified underneath that organization. Now you can choose between implicit or explicit or UCMM. So for those that don't know, explicit is when you're pulling for data, and then implicit is where you're just sending it without even being asked. It's just implicit communication. It's implied that you need to send it. So how easy is this protocol? I would like to compare it to OPC UA. The IO device is typically going to just be it's just going to be the name of the tag or the name of the variable that you have over there in the Ethernet IP device. So whether that just be pump one status, or maybe it's I don't know, VFD frequency, something of that nature. We'll call it a float. This will communicate with that IO device, the Ethernet IP IO device. So it's similar to OPC UA in the fashion that it's a simplistic way of doing IO addressing. So we do support Ethernet IP. Just wanted to put that out there. And then you're more than welcome you're always more than welcome to not have to purchase the hardware, but open up the online simulator here in the Canvas software and test it. You don't need to purchase the hardware at all. I think I had to allow something, my fault. And then it showed up here, right? 1 second. So the Canvas simulator here, right? This will behave as an OPC UA client server, MQTT publisher, Ethernet IP, whatever protocol you choose, you can test it out with the simulator before even committing to the hardware. Just a heads up, you never have to commit to the hardware before you test something out. So again, that's located here, the online simulator. Now, one more protocol that it was not talked about in the description of the webinar, but I want to talk about it, is very important, is SMTP. So that again is for emails. So the HMI, the X panel, the NXT-EXT is capable of emails and text notifications. So no, we don't support SMS, but for those that don't know, SMTP can be used for SMS. So what do I mean by that? So let's say that you have a phone number, and then you have Verizon as your carrier. So if I send an email to this permutation right here, this string, it will actually send a text message to your phone. So you can take full advantage of Verizon's email domain, and you can send a text message that way. So you don't always have to send an email. So what I'm saying here is that with the SMTP server that we provide, or the SMTP server we provide, you can either email or text. Just make sure that you check on what is the domain for that cell phone carrier that you're using, right? So for me, I use Verizon, so it's vtext. I'm pretty sure there's one for T-Mobile, Cricket, Mint, all of those. At the end of the day, they should all have some type of domain. And with that, that would conclude our webinar for today. I'm sorry I ran over by 5 minutes. But if you want to learn more about these protocols in a more intimate session, you're more than welcome to contact support@CIMONinc.com or call us at 702-820-1060, option 3. So we can set up a 1-hour session, get you going. You're not always alone when you're setting up any of CIMON's equipment, or when you're just getting with CIMON equipment. Or getting started with CIMON equipment. If you want like specialized training, you're more than welcome to contact us. We can talk about your application, get you going. But with that, I hope you guys have a great rest of your day, and look forward to the recording and all the literature that I provided during this presentation.